Thanks for the invitation here. The workshop has been a great experience, and I'm excited to get to share some of the work from that, as well as the rest of a kind of body of my work as well. Hopefully contextualize the work that we did this weekend for some of the participants in it also. So today I'll be positioning a body of my own work next to some current trends, making an argument that we are currently in an era that calls us to rethink historical methods of geometric ordering, analysis, and operation, regaining lost arts of the past. This lecture will also address two roles, or the role, rather, of two technologies in particular, 3D scanning and generative AI, questioning the ethics of the seamless, thin shells they tend to create, and a proposition for a more honest and generative way of working with them. Throughout the history of architecture, architects have worked with referential source material, sometimes relating to a previous design language or to previous design languages, cultural signification, or the actual source material of the site. Early architecture was an architecture built from the earth, using building materials directly extracted and found in the places where the architects built. Architecture was one of volume and mass, carved materials often thought of through intersection, as in stereotomic projection, or subtractively, as in the carved stone cities of Cappadocia in Turkey. The architects of the time were master masons shaping stone and carving the earth with gesture, craft, and material sense. They were archaeologists studying the earth for its properties and creating directly from those properties. As architecture moved into 2D projection, the codification of the orthographic drawing flattened the way in which we worked. Early architects still acted as master masons with command over the mathematic principles of geometry, but as the knowledge of both slipped away, the discipline's drawings led to three-dimensional projection that relied primarily on methods of extrusion. High-resolution mesh modeling and digital sculpting create intuitive design practices, sculpting with mass and deformation of materials, enabling us to consider the material properties of things around us, acting as digital archaeologists, unearthing the architectural potentials of mass and volume. These historic cities in Turkey are both additive and subtractive, are of the earth and directly tied to the material of their site. These architectures are incredibly contextual and work through processes of excavation and grafting rather than extraction and assembly. This work ties material, texture, elements, and space all together into one volumetric carving process of formation. As a monolithic whole, the architecture degrades and weathers over time, changing its reading, offering new edges and features within the solid mass of architectural artifacts. Digital archaeologies would not be possible without the translation of our physical world into digital reality. Our technologies now give us access to an incredible amount of data which map the relational networks around us. Photogrammetry and LiDAR scanning give us the closest fidelity to a one-to-one relation to our physical world, capturing material decay, lighting, color, geometry, vegetative growth, and assemblages of things not typically captured or considered. These tools have led to massive online repositories of cultural artifacts. If we retrain ourselves as architects to work with this one-to-one capture of the world, we can regain the notions of gesture and craft, but this time not at the scale of the individual block or material being sculpted, but instead at the scale of space and building, carving with artifacts of the past to create new speculative futures. Photogrammetry, a multi-view camera alignment and projection process, creates 3D models from triangulation of points in each photo, constructing matching features that develop a cloud of points, which can then be converted into a high-resolution textured mesh. In this workflow, photos are aligned in space, and then the points are projected and triangulated to form the resulting captured mesh. They can be instantaneously captured or sequentially captured, as in this example with drone or UAV capture. The scanning process can be done terrestrially on the ground or aerially using UAVs with LiDAR or photogrammetry. LiDAR is like photogrammetry, but instead of aligning features within photos, it projects a laser into space, capturing depth data as well as color information, translating into clouds of points matching both of those. Now we are seeing the ubiquitization of 3D capture with mobile apps like Reality Scan and Polycam, which can be used for photogrammetry on the mobile, any mobile device. And if using them with newer devices, you can use them even with LiDAR scanning in real time. This has rapidly increased our access to the capturing of data in our physical environments at nearly one-to-one resolution. This is a paradigm shift for the cataloging of designed objects, spaces, and architectures. Professional software like Reality Capture develops these captures into high-resolution meshes, which represent the capture as a thin surface in space. These meshes contain both geometric and texture information from the scanning process, collapsing lighting, material effects, and geometry into one surface. These captures collect weathering and the temporal evolution of architecture, allowing a near non-reductive view of the things around us, whereas previously we would draw these structures, abstracting their features so we can understand them. One difficulty that emerges is that of processing the large amount of data associated with these meshes. The resulting meshes can be extremely costly in terms of computation and difficult to manage. With recent developments in hardware and more efficient computing, this processing is readily available to the average consumer within a few minutes, and free educational licenses to the best professional quality tools for this type of work. This type of capture drastically changes the way we see and analyze our world, opening new scales of capture, viewing, and never before seen representation opportunities. These surveying tools are analytical opportunities for architects not to replicate artifacts of the past, but to work with the canonical projects that came before us. The goal is to understand history, form, and material, and to tune our aesthetics to a much broader cultural spectrum. Technology allows for the digital cataloging of styles, cross-comparing form and scale, and sequencing of space. Through these tools, we can find never-before-viewed representations, recomposing things of the past into hybrid assemblages of the future. My colleague at the University of Pennsylvania, Andrew Saunders, is one of the key figures when it comes to architectural capture using 3D scanning. In 2016, he received a grant in partnership with the LiDAR scanning company Faro to 3D scan several of the most famous Baroque churches throughout Piedmont and Rome. This work extended the formal analysis of Heinrich Völklein in Renaissance and Baroque, among many others, establishing a 3D comparative set that allowed for contemporary analysis of these spaces. Andrew developed, for the first time in history, 3D point clouds of the interior skins of these churches, which we could capture and view from the exterior. He called these views the veduta per angula, or the view of angels. Another representational type that he developed mirrored earlier works by Luigi Moretti, who cast spatial voids as positives in plaster, studying the sequencing of space and formal properties. Andrew calls these views spheroidal cosmologies, which are top-down views of the church ceilings, showing the variation in geometric language of space, approach from each Baroque architect, and a coordination with their developed specialties. Each architect specialized within classifications that Andrew has denotated in painting, sculpting, geometry, mathematics, or building. And each aspect can be shown in the sets captured by Andrew, revealing the bare ceiling of a church with painted coffers, so removing that kind of paint layer or textural layer, or the incredible multiplied edge of many others. These sets open new representations, new vantage points, and a collapsing of the painting, texture, spaces, geometries, lighting, and much more onto one thin, continuous surface. Working with Andrew in his Baroque topologies course, we developed two new representations for this catalog, including the hinged section and the sheared oblique. True obliques, without a higher degree of abstraction, can now be shown for the first time of these interior spaces, measured with all of the ornament and detail captured within the geometric edge, expressing the surface folding of the Baroque, which enamored many philosophers, in particular Gilles Deleuze. Projected in the same space, these obliques give access to a multiplicity of views, collapsing exterior and interior, vertical and horizontal, into unified compositions. This formed a process of re-seeing the things that were previously very familiar. It made generative this referential source material and provided new ways to analyze and compare between churches within this set. In 2019, Veronica Skepa, Cecilia Lundbeck, and Ulrika Carlson developed a series of representations exposing the hidden poché and thin surface of similar three-dimensional scans. Like Andrew's sets, these scans allow us to re-see, this time the ordinary and mundane of the world around us, and readily available to us. But here we see poché not as the cut through the wall, but as all of the inaccessible space hidden by the clutter, furniture, and things that occupy our architecture. This work is written extensively and very beautifully about by Michael Young in both his new book, Reality Modeled After Images, and an essay called In the Shadows of Information. These are fragments of the everyday, but make indistinguishable the importance of the plant on the shelf, the curtain hanging, the trash can in the room, and the book stacked upon surfaces. This series again promotes 3D capture and digitalization as a drastically new way of thinking and seeing and making reference to things otherwise unnoticed. This type of work is an assemblage in every sense of Jane Bennett's use of the term, where the vibrance of causal elements strewn about emerges to the foreground to be felt and appreciated within its sometimes chaotic relational environments. In 2019, I traveled throughout France and Belgium, collecting multi-scalar artifacts of the Art Nouveau period. The goal with this set was to establish cross-scalar comparisons in the gestural features present in the works of the Art Nouveau. The problem was trying to transcend the referential sources for these objects and develop generative methods for designing new artifacts, but preserving similar qualitative effects. I developed two approaches to solve this problem, one using machine learning and the other using digital sculpting techniques. I had written several machine learning models to navigate features latent within these collected meshes. I also developed a web app for vector arithmetic, meaning you can actually navigate through using mathematics alone, adding and subtracting qualities of images to one another, randomly surfing through these kind of generative models, or cross-comparing or interpolating between images. Some of these techniques are now kind of familiar in the more proliferated models that are more accessible to us today. I also wrote my own generative adversarial network trained on the images required to capture these three-dimensional scans. So their requirements were a kind of multitude of images, several hundred images per captured object, with several hundred objects captured in the set. I ended up with several thousand images, which were useful, and then building a data set for their later use in these models. Then I also developed a three-dimensional projection method based on Hugo Hop's geometry images paper from 2002 to smoothly interpolate between three-dimensional generated models. So one of the key aspects in translating between this kind of 2D and 3D positioning of the work and some of the captures and kind of making better use of maybe the material textural qualities in coordination with the geometric qualities was to use a kind of base topological object. So a sphere, a torus, a two-hole torus, a kind of figure eight. And basically what they would do is analyze how many holes were present in the base mesh topologically, route it to some base topological geometry based on that number of holes, and then you can create a parameterized set of images, kind of normalize the data for these AI models. So on the bottom there is the example from Hugo Hop's paper from 2002, and then the middle section is my translation of similar work. Something I questioned constantly in this work was the role of reference in machine learning processes. Was the goal to increase fidelity and proximity to the inputs in the dataset? If so, at a certain threshold, do the images and geometries not just become identical to whatever their reference was? And where is the designed or generated value within them? The other issue was the nature of these models to work with surface folding and continuity, so the continuity of these kind of thin surfaces, falling into the trap of some early digital era issues of the single surface project, so the kind of avoidance of parts. Architecture is composed of parts, so at some level, the design production, I think, should also reflect this. The other side of my development was a more manual process, working directly with collected artifacts and digital sculpting techniques to create methods that, like the machine learning model or machine learning processes, could extract qualities and familiarities from referential material using 3D scans as a base, but not relying on the denotations or kind of meaning contained within the original. So that means the meaning at some point in the process has to become severed, or those associations have to be removed in order to kind of work with them more fluidly or freely. The first step was a curation of tools that vary in scale and features, which can then be read thoroughly, analyzed, and deployed. The flowing fabric wrapping figures intersects between where these figures actually combine. So this may happen at different scales, abstracting the original reading of both. So there are kind of new relations between both figures, and the intersections between them already work to provide one kind of act of severance from their original meaning or denotations. Notions of space, movement, occupation, interior and exterior can be read in these models as a kind of default or byproduct of the 3D scanning process, and they leave a trace in the outcome, ideally decontextualized and not wholly registering, but of something familiar present in the design output. So these are still just the kind of tools collected and curated to then work with in these digital sculpting techniques. Like Luigi Moretti's plaster cast, we can use the positive of interior scans to carve away spaces into new sequences, starting our architecture not with the abstract box or the empty sheet, but with the best architectural spaces that have ever existed. Circulation in this kind of workflow is not merely egress, in this way of thinking. Instead, it is carved connections between voids, integrating and freeing us from some of our preconceptions. So all of this is able to kind of integrate and act fluidly, building up certain kind of tropes or biases in the process where these voided figures often are subtracted volumes. The kind of smaller scale figures are often they require intersection to be able to kind of divorce them from their prior silhouettes, gaining a kind of new meaning or reading. In the film, video game, and sculpting industries, high-resolution modeling programs are ubiquitous. These industries leverage platforms like ZBrush to increase the efficiency of their modeling workflows and to give them access to an enormous degree of agency and detail in their work. These platforms are gestural and emulate certain actions found in sketching or sculpting, like the pressure sensitivity and malleability of form. These tools give architects access to the masonry techniques that were lost in the profession years ago, and draws an analogy to our industry's historic building methods. This is not, however, a romantic return toward history or that specific way of designing or building. Rather, these tools combined with digital fabrication bring new life to innovation and technology in the aesthetic arts. They allow us to again leverage gesture and craft within more repeatable fabrication and assembly systems. Macros and procedural scripting can be paired with gestural and intuitive workflows to regain a craft of the past within the technological precision of today. What we can look for to successfully retrieve an artifact from its past is a moment of emergent form, freeing the figure from the plastic rock of the digital sculpting interface. This act of emergence or obscuring of the known and readable object helps us to not act reductively and symbolically reference elements in our toolkit, but instead re-see them and reveal certain properties that lie dormant within them. Both Rodin and Michelangelo, among several others, but I like to kind of specifically look at their work, beautifully captured the figure-crushing power of mass, reducing the most powerful cultural emblems and architectural figures to bound figures within the mass that they emerge from. The tool leaves its imprint and is directly tied to the form, where surfaces are hewn or rough, freeing properties of the material from within. There is an intimacy with the geometric features of these sculptures, where the artist develops a keener eye because of the close nature of their sculpting process. So even cast models are left with seams that run beautifully along the geometric edges. In these sculptural processes, form is tied to material. Intuition and gesture develop an aesthetic sensibility in the artist and the viewer. This way of thinking establishes outcomes that have familiar qualities, but as a whole are estranged. Space gets cast into new scales, with new materials not acting symbolically to preserve any semantic identity of the original, but indexically developing quiet sympathies with its viewers. So these kind of local features are present, but the holistic compositions or readings are lost. By starting with 3D scans, their own materials and textures influence our reading of material, texture, and scale throughout the design process, integrating weathering, scale, finishing techniques, material conditions from the very start. These models all come from a reconstitution of the previously shown model catalog. They are ways of thinking of architectural fragments, spatial carvings, and pseudo-architectures. Custom display previews can be set up to give the sculptor better awareness of the geometry that is being created. And with a view-based gestural interface, the designer is always looking at the thing that they are modifying, unlike many CAD-based software, which trade expression or the expressive nature of the work for the measured and kind of controlled qualities. These quick previews give real-time feedback to the designer and accelerate the iterative process. This is a critical point in this work, though, I think, that needs to be kind of understood further, which is that all actions being performed, with the exception of kind of pre-scripted actions, although even those can be tied, to the kind of viewing of the object, meaning the eye of the designer is always engaged or implemented in the work being done, which isn't always the case when we prescribe the creation of a box or the creation of a geometric primitive in a software like Rhino. These gestural and referential workflows are often top-down through processes with quick feedback and plasticity of form. How does this work within systems of fabrication that require a logic of parts or assembly? How do these top-down processes engage the referential position of semiotics? Do they become icons, symbols, or indexes? And are they reduced to their semantic source content? To see the vibrance in the assemblages of things around us, we need to reference not the semantic conceptual identity, as Jane Bennett mentions in these quotes, via the icon or the symbol, but through a hyperindexical meshwork or operation of assemblage and decomposition. So not referring to the kind of embedded meaning of something, but instead looking at its relationships with the things around it and developing a kind of understanding of its qualities based more on that. This is not a mereological process of parts or top-down system of symbols, but a substitutive feature analysis of hyperindexical relations. Discussing ornament in his text, The Nature of Ornament, Kent Bloomer describes a process of decontextualization or abstraction, which natural artifacts must go through to prepare them to be received by their functional architectural body. This is a semantic severance that enables the reconstitution of artifacts into a larger assembly of architecture. So specifically, he's talking about these kind of natural references that have to be kind of symbolized in some way or abstracted as a kind of graphic to then be placed within these repeatable systems to then be used as ornament. Much of the recent work in machine learning falls into, I would say, this same kind of issue, which is that the model runs in a kind of bottom-up way, something that is operating more hyper-indexically, but often our engagement as users comes more from a kind of top-down prescriptive level of engagement. Also, the output it produces a kind of seamless continuous output image. So although the model is operating at multiple scales, our human eye and mind sometimes can't operate in that same way, analyzing and registering those scales in the image. We register them as kind of qualities of the whole, but it can be quite difficult to actually differentiate them. So even in these images, if I asked 20 people to draw the figures or parts within it, everyone would probably struggle to do so because of the kind of continuity and interlacing that occurs in these models. Through an act of disassembly, we can discretize these seamless images, aligning this process with the perceptual features of the image. Using JPEG compression algorithms, we can perceive the qualities of the whole while producing an economy of parts. So basically, the decomposition of the image is tied to the actual properties in the image, so the pixel data and how the eye is meant to kind of read it. So it's trying to kind of minimize the number of parts, maximize the aesthetic effect or the reading of the image. So this starts to establish a kind of hierarchy, a breakdown, maybe a severance that occurs in these machine learning processes. This process uses machine learning models and algorithmic processes to construct assemblage out of the seamless and take a step toward making more useful these static images we are now used to seeing. And I say static images because they can be quite difficult to kind of move forward with if we don't build these kind of iterative interpretive processes into our workflows. So, if the process is to generate an image and then it stays there, I would consider that kind of static. We should look to kind of make better use of these really innovative and exciting methods. So starting with an image of a facade, we can selectively remove parts. The remaining parts then have to carry the load of the removed pieces, trying to reconstitute or reimagine this image with as much integrity of the entire image from the original, but no longer having all of its parts. So maybe that first step is less noticeable, but as we remove further parts, we detach more from the original image. This creates a kind of economy of parts that exists also within fabrication, limiting the required elements needed, so possibly limiting the number of molds required, but maximizing the outcome of the compositional effects, the qualitative effects. Eventually, the image becomes less recognizable, but the parts are limited to a handful of unique elements that still act to recompose the kind of compositional integrity of the original, losing meaning, but preserving qualities. Through fragmentation and sorting, using machine learning models, we can leverage the multi-scalar view of the machine to open our window onto non-identity and destroy human conceptualizations. A simpler way of stating that maybe is that these are not classifier models. They're not trying to prescribe meaning, semantics, an identity necessarily to these things, but instead are just looking at pixel compositions and kind of comparing in that way. Comparing assemblages, not symbols. So this creates these kind of mosaic compositions where even the resolution of the pixel, some of the kind of largest scale tiles become the lowest resolution image, forcing the eye into the deepest portions of the image. So the smallest tiles are actually what kind of retain the most resolution and kind of draw the viewer in, which to me, it creates these kind of metaphorical structures which I think can be incredibly exciting just as compositional things. But they also speak to this language of the kind of digital materiality, the material of the pixel. And when the pixel is actually registered, it becomes almost a tectonic block or element to transform the reading of whatever that original piece was. This also helps to kind of question the scale of it, maybe to kind of position it at a new scale. Operating with 3D objects, these models align preset elements into compositions defined by the designer. Limiting the molds required, attempting to blur the seam between parts, and constructing new figures shared between them. The goal of these compositions is to achieve this sort of territorialization of heterogeneous parts that Manuel de Landa discusses in his text Assemblage Theory. So disparate elements that interrelate, something that exists at the core of architecture, which is how do we construct a kind of unified or cohesive whole or some understanding of the larger composition from individual part relations. So within these compositions, the goal is not, it's not saying these are the most successful achieving this goal, but the goal is not to just register the kind of rectangular bound being projected on or clipping these three-dimensional scans, but utilizing these machine learning models to try to stitch together as to the best of their ability connections between these kind of figures or silhouettes inside of the tiles. So going back here, we can see some moments where the tile actually starts to blur, maybe in the lower left-hand corner, where we actually have 3 tiles that it's quite difficult in these kind of larger portions to see where that kind of seam is. In other areas, the seam is more present. As the kind of tile gets smaller and we see the repetition is what is kind of aiding in telling us what the tile actually is. But all of these are composed of a fixed number of tiles. It's been a while, but I think this is like less than 4. And it's up to us to kind of define that relative to the scope of the project, the time required, how many molds you would like to produce, and then these can be quickly kind of produced as plaster relief tiles. This process was developed into a studio that I taught in 2022 at the undergraduate level at Texas A&M, which dove into ideas of assemblage and material vibrancy to create post-industrial tower houses. So these are just images of the exteriors, but using conditional GANs and variational autoencoders, as well as three-dimensional sculpting and automated texture projection, the students worked to decompose the original reference and reconstitute a whole that retains some kind of aspects of the familiar source, but recomposed into kind of new assemblies. So whether that's kind of, mechanical systems shown to kind of give a sense of scale, or the brickwork itself, but reduced to texture and image, the scale of the brickwork is able to kind of freely scale, starting to even question the module of parts at the texture level and not even the kind of geometric level of blocks. So our preconceptions, about construction often limit that kind of freedom. So here we start with this kind of freedom of expression that can later be kind of clamped down or specified as needed. Later, this work was integrated into an advanced studio at the University of Texas at Austin, where the students worked to kind of build these mosaics and then use more current and kind of accessible models inside of Comfy UI, using models of diffusion to kind of reproduce this somewhat seamless nature, but in starting with the tiled images, So in starting with a decomposed composition, we still have a kind of registration of those original parts. So in some way, I think they make these AI images more accessible to the viewer, understanding how we might actually break it down, because we start to see the seams projected into the image. That being said, this takes some of my earlier work maybe one step further, where the seam is sometimes even harder to actually register. Building up ideas of materiality, growth, weathering, and systems, all composed into these kind of assemblages. More recently, in the two-day workshop that I just delivered here at the TVLab at Michigan, we started with a base set of 3D scan mesh tools, similar to my process that I showed earlier, and developed figural objects that composite scales, materials, and textures. These digital sculpts are holistic compositions made up of disparate parts. They can take on new materiality and are cast into a new spatial scale. To decompose these 3D wholes, we used OpenCV, so computer vision, to segment images of the models, operating on the perceptual clusters developed in the work. This, paired with mosaic tiling systems, tie aesthetic difference with economies of parts, substituting and reducing the elements, and constructing vibrant assemblies of heterogeneous part. Cast back onto the 3D models gives a kind of hybrid flattening and starts to draw new seams onto the complete figure. Participants constructed images from these models and tiled images, the models and tiled images as a kind of base, using Comfy UI to run generative AI models to kind of restitch them together. So starting with a three-dimensional object that brings with it some ideas of kind of scale or material, capturing some of those qualities baked into the 3D scanning process itself, and then from that, decomposing them as a kind of image, tiling them, and from that tile process, then kind of generating these more seamless, holistic assemblages. The goal is to develop vibrant material assemblages that register parts in some way, but work with the seamless nature of machine learning models to compose them into complex and difficult wholes. So work with the AI's ability to kind of process this at a higher level, a more interrelated and complex level than we may be able to, but using this kind of decomposition to help keep us as a part of the process, retain our agency in the process. This is a kind of game of features and feature matching. So the development of specific features that are identifiable, and then using these models as a kind of feature matching device. Tuning our eyes as designers to what things in the compositions are preserved, and then what things are lost. Allowing a closer reading of our own work, constantly operating in a kind of multi-scalar and iterative way. So it forces us in some way to zoom our eye constantly like into the image, out of the image, look at the part relationships, but then also kind of look at these holistic compositions. So it exists not as discrete or kind of continuous, not as top-down or bottom-up, but constantly fluctuating between them through this kind of iterative process. These workflows and processes are a way of re-seeing referential material at each step, again, positioning discreteness against continuity to achieve the assemblage as described by DeLanda, or at least that's where I kind of come to this notion of assemblage. So this idea of heterogeneous identifiable parts, they are identifiable, but also their relationship to each other are also identifiable and create these kind of larger clusters, and then work to kind of exist within larger wholes. So this work is from a 2023 exhibition at Ball State University, where I built these workflows into a collection of objects, artifacts, and architectural fragments. CNC milling some of the pieces at a larger scale, 3D printing some of them, but allowing the kind of seam to register, breaking down the kind of figure, and giving us access into these models, whether that was digitally sculpted models referencing three-dimensional scanned source material, or using these kind of machine learning models as a prosthesis to help me see and understand and interpret the kind of features and qualities developed. This work paired fabrication, optimization, and efficiency next to more theoretical questions of how we integrate reference, define qualities, and create novelty in design work. A series of augmented reality models allowed for each part to be explored separately and larger clusters to be activated, exploded, pulled apart, thrown in space, really whatever anyone wanted to do with them, but to investigate the relations of the part within the whole. In much of this work, machine learning is used as an analytical tool to help me see the work that is already in front of me. It gets me closer into the things being created rather than cognitively offloading a part of my design process and removing me further from what I create. They create perceptual hierarchy and figural intersections, which act as a kind of stereotomic projection or cutting of volume into block. Each fragment was animated, and then the animations were used to develop scans, to then work with these augmented reality models, baking in lighting, material conditions at a much higher resolution, but still allowing for the kind of efficiency and optimization of a real-time augmented reality system. What started in a digital capture of the real world through photogrammetry allows for new ways of seeing our digital geometries. Our digital toolkits are opening, and the geometric types are topologically shifting in order and kind, where our task is to consider what these tools allow us to see and do different to the early master masons and geometers of the past. What is the stereotomic projection of today? In the past, we used traits or flat, unwrapped templates that folded to create the three-dimensional form of carved stone blocks, but today we often operate directly in 3 dimensions first. What does the re-seeing of three-dimensional form through unwrapped skins offer us as architects and designers? Does this get us closer to the master masons of yesterday or bring us toward an entirely new geometric order? So I'll leave you all with this last series of images, tying these ideas of stereotomic traits and projection, unwrapping three-dimensional geometry, but conceptualizing it in that way and actually then fabricating it in 3D. So here we see those kind of skins of these augmented reality parts that are unwrapped and allowed to be kind of displayed with all of the seams, material, lighting, kind of captured all at once. So these workflows are to build up ideas of representation, re-seeing, but also as a generative method for us to kind of interrelate parts to more complicated and unified wholes. And one last kind of point here is I believe there's a kind of like politics of the seam embedded into all of this. There's a somewhat of a truthfulness or honesty where we register the parts in this type of work that I think is lost in many of these generative AI processes today. So we need to find ways of kind of iterating through and using these models, not just through generation or for generation, to kind of offload a part of our process, but within larger kind of workflows and more as a kind of prosthetic for our own analysis and interpretation. Thank you. And I think I'm maybe close on time, but it might be a little bit late, but I'm happy to answer any questions or have a kind of larger discussion if anyone has them. Yes.
Yes. When it comes to textualizing your own textures, what was the process that you achieved of getting that? holistic research to, kind of visualizing that and also generating this software to kind of implement that and project that out to
So I can answer it in like a kind of theoretical, I guess, as well as like maybe a technical. So I'll do both in case your question lies somewhere there. So like one part of this was from the early stages in scanning the Art Nouveau artifacts. So much of their qualities are tied to the kind of material qualities, and how even the surrounding, like, whether they're displayed in a museum or they're actually embedded into an architecture, like what is the environment around them? And I just noticed, that any level of me trying to capture or work with them or bring that into my own work, if I was just abstracting them to their gesture alone or just the kind of geometry, that there was some loss in resolution. And for me, that was like, not acceptable. I wanted to find a way of bringing as much as I possibly could. So 3D scanning was the first step in that, where it helped me to kind of see more material and where material and lighting actually becomes flat digital texture. And I kind of like this ambiguity between these. Like for my own work, I feel that it's really productive thinking about actually fabricating using robotic workflows. So like whether it's 3D printing or milling or whatever it is. But there's a process of layering and creativity that can be embedded there in the physical processes that can be directly tied to these digital ones. So sometimes I think it's unfortunate we say, oh, this is just, even the image we're looking at here, it's just a digital texture, it's flat, it's just a graphic, it's not actually a material. But for me, the difference is like, are you understanding the actual kind of properties that can exist? So like the reflections, the lighting, deeper properties than just color information. And this exists in the kind of 3D scanning. It exists also as like misreadings in texture on the surface. So sometimes what is actually just painting actually comes in as texture. It's one of the most interesting moments from me learning from Andrew Saunders' work and his collection. That where they are painted surfaces and we actually see them without the kind of painted surface, it reveals something, more to us. Like it actually, I think, brings up the value of that kind of graphic, because we actually see how they're able to paint depth into these kind of works. And on the original scan, you don't even notice it. So it, like, what is the difference? The effect is the same. So, I would question what the loss in value is that sometimes people can see. So I guess that's the kind of theoretical framework. Like I knew I had to be a part of the work because of that. So at each level, I just tried to bake it in. Machine learning models are the accessible ones are often image-based. I work with other types, but in specifically the image-based, there's a kind of viewing and a image projection or a flattening that needs to occur. So these now being flattened could directly be worked with in any 2D process. So there's something there that kind of developed. In terms of like technique, I think, in the same way I'm talking about severing, it's like really just specifically looking at almost like the metadata or the layers of information that comes from each of these stages. So seeing first, like, okay, in a 3D scan, what do you get out of it? All right, you get like the geometry file, you get the image file, among maybe other things, but let's just say that. So you can kind of work with them in those separate avenues, or you can look at that and say, okay, if this is the way we're capturing the world, then isn't that also the way we should kind of project our own work back in with like texture and material information with geometry paired back and sent forward? So, part of my hope with things like this is they end with more material condition than the 3D scan that they started as, so that I'm actually like pushing them forward even more. I don't know if that exactly answers.
No,
Okay. Mm-hmm.
So definitely.
Yeah, I'd be happy to.
How important when generating, sorry.
It's, yeah, it's like I gotta get some sunglasses.
How important is it to move yourself from the generation of your matrix when you're generating textures and patterns to like remove like personal bias to like which textures to move on to like pursue this texture over the hundreds of textures that and patterns that you
Yeah.
generated?
Yeah, that's a really good question because I sometimes talk about it a lot where it's like, oh, I have to like sever it. I'm trying to like detach my conceptualizations or whatever. That Jane Bennett writes about this a lot in terms of like philosophy and kind of politics. But she writes about this idea that like, we carry with us kind of baggage and everyone carries their own biases with them and their own interpretations. She talks about though, like looking at something and trying to find this deeper, vibrant materiality. So the kind of quality baked into the thing, but not with my particular like cultural background associated onto that. And I think in her text, it's called Vibrant Matter, and it's a beautiful book. I highly recommend anyone reading it. But she talks really beautifully about this kind of search. But even in discussions that I had with her about the Art Nouveau work that I had done, part of that was disassociating the symbolism to try and look for more shared qualities between those things. Because often the Art Nouveau as a movement gets flattened down to like, pure symbol that's projected into architecture or something. And I think people use that to diminish some of its successes. So I was trying to kind of take that approach to it. But she said something that's really beautiful that I have in the kind of quote slides. I think I maybe quickly went through, but she talks about this idea of the not basically the non-identity or like removing this conceptualization, so the hubris of conceptualization. All she's saying there is like we tend to overlook a lot of things when we think we know what it is, and then we know what it is, right? Like immediately we just move on because we think we know what that is. If we always come with the assumption that we know nothing about it, then we'll look a little bit deeper. So some of these really like complicated, kind of difficult images to see the mosaics, it excites me because those are images that are difficult for me to read. And it makes me question where the kind of value is. So yeah, what I think still my intuition and my like design language is a part of the work. I'm not trying to remove that. I'm trying to remove some of my preconceptions, some of my like kind of negative assumptions about like what I might be seeing, and negative only in the sense of like that they're short. And I just kind of briefly glaze over it, and I might miss something that actually is embedded into it. So yeah, it's super important for me to do it, and I try and do it as often as possible, and I use these like algorithmic methods to try and help me do that, to kind of step outside of myself. And maybe just to leave this on this point, like why would that be important? Maybe it's obvious, but like I'm just me. I can bring my own intuition, but someone is gonna kind of view and interact with this, and if I'm trying to build a kind of sympathetic quality within the work for someone else so that they can relate to it, then it's probably good to start detaching my own biases and then allow the work to exist elsewhere so that other people can view it in their own way. So that's part of the issues with, embedding symbols is that sometimes they have particular connotations and it might be misread. Yeah. Any other, I can't see if anyone else has questions, but yeah. Okay. Yeah, yeah. Thank you guys for coming.